But now I want to continue with Professor Ahmet Türer. He's head of Civil Engineering Department in Middle East Technical University. He had his PhD in United States in University of Cincinnati. He is giving courses on timber structures, Eurocode 5, and also he's experienced in historic structures, bridges, structural evaluation, condition assessment. From point of earthquake risk in Turkey, he's doing great works and academic studies. So floor is yours, Mr. Türer.
Göksel Bey, many thanks for your kind introduction. We have approximately 10 minutes, so I will try to make the best out of it. I have prepared a presentation too. This is going to be from a structural point of view, if I may. So it's an engineering perspective, so there is architectural too. My presentation has these 5 items, let's say: current use of timber in construction, safety, technical regulations, cost comparison, and psychological barriers. When I talk about current use of timber in construction, I will mention a little bit about Turkey too. Although historically Turkey has been using a lot of timber structures in the past, currently we are not using it anymore, and mostly reinforced concrete is the type of construction in Turkey. Now, for the current use, as structural engineers, we can use solid timber, but increasingly amount of times we are switching to glue-laminated timber, which individual parts are glued together to form larger cross sections. Because with this technology, you can not only have curved members, but also you can have very deep cross sections for columns and beams, and you can span larger distances. Timber being a lightweight structure, combined with the high strength, it is a structural engineer's dream. And today in United States and Canada, 95% of the houses are made out of timber, whereas it is less than 5% in Turkey. So there is a new technology, relatively new, which is called cross-laminated timber. In this, it is like glue-lam, but the orientation of the members are alternating 90 degrees to each other, so that you can have a plate that you can use as a shear wall or for the slab. Finally, all the sawdust you get from cutting timber, you can glue them together to make particle boards, either MDF, HDF, or coarse particle woods, or you can shave the timber from trees in thin slices, and you can combine them as plywood, LVL, LVB, and other material. So there's a major difference between LVL and LVB or plywood. The layers are either 90 degrees or parallel to each other, 0 degrees. So by this, they are either used as a plate, as you see here, or as a beam, as a structural element. There are more varieties. There's no time to go into each sub-segment. Laminated strand lumber, parallel strand lumber, oriented strand lumber, and composites, of course. Here you see a beam. The web is made out of steel, and the top and bottom flanges are from solid timber. Sometimes it's combined with steel cross-section, and glue-lam, solid timber, steel, they go all together nicely. And in this example, you see a very wide arched type of structure with a large span and composite cross-section. Now, the structural use of these materials or segments can be categorized in a variety of ways. I will just mention a few that are most frequently used. Post and beam method is just like what we are used to with reinforced concrete. We have columns and beams, so made out of timber. There is a light frame construction where the load is carried by the walls instead of columns, as you see in here. This is very frequently used in America too. You can make private houses versus apartments as well. You can go easily up to 10 floors. And if you notice, sometimes the first floor is out of reinforced concrete just to keep the humidity out, but it is not mandatory. There is the prefabricated version where most of the construction is completed in factory and they are logo combined on site, which is very fast construction. And there are some nice examples as you see here. Sometimes it even comes with the window door openings or the windows and doors already installed. So CLT construction here is an example to prefabricated, and they are like very fast construction. There's the pole buildings. This is agricultural and not very frequent, but I just wanted to mention it anyhow. The columns are out of poles like timber tree trunks, and this is frequently used in the countryside. Well, historically, Turkey had wooden houses since 16th century. There was a very big earthquake in 1509 in Istanbul, and Sultan back then has commanded that all of the houses will be constructed out of timber from now on. And for the last 500 centuries up to 20th century, it was timber most of the time. We have historic structures made out of timber, mosques more than 800 years old. And here are some examples from Safranbolu, Kastamonu, Beypazarı, close to Ankara, Rize. So as you can see, they have combinations of stone plus timber, and timber only. So they use all kinds of innovative use. Sometimes part of the building is one kind and the other part is different types of timber and stone. Here's an example of a mosque, which is 8 centuries old. We have traditional timber houses by the Bosphorus Strait, which are extremely expensive. Well, this was a general overlook, so to make better use of my time, I will go a little bit faster. When it comes to safety, there was this small doomsday, and Sultan Bayezid II ordered, as I have told you. He has seen a very basic principle that is known from 16th, 17th century. Well, Newton knew this when he had the apple falling on his head. Force is equal to mass times acceleration. Acceleration is the earthquake, and if you have a light mass, then you have a smaller force. So D'Alembert's principle also falls into this, even Einstein's. But to make things simple, you can imagine a structure on a vehicle, and as the vehicle is accelerating, the inertial force acting on it is going to be in the opposite direction. So earthquakes are just like that. If you have a light structure, the forces are smaller. And if you have a strong material, then your building wouldn't collapse. So with timber structures, our capacity is high and our mass is low. So it is the perfect combination. Here you can see a comparison of timber, concrete, and steel. Timber is about 300, 500 kilogram per meter cube. Concrete is 2,500 kilogram per meter cube. Steel is almost 3 times that. But strength-wise, this is 30 to 50 megapascal, and this is the characteristic strength. It can easily go up to 80 megapascal or so. and concrete is typically 30-35, and steel is within this range. So if you normalize with respect to the mass, timber looks like stronger than all when you normalize with the mass. So we have up to C50, 50 megapascal timber in softwood, up to 80 megapascal in hardwood, and these are all characteristic strength. So 80 megapascal means 95% of all of the samples you collect are going to be equal to or larger than 80 megapascal. Technical regulations in Turkey, we have Eurocode and TS 649 in effect, but usually municipalities and the Ministry of Environment and Urbanization produces national rules and regulations. So we will be working on this this year and next year. Hopefully they will be out soon. And also some review mechanisms and procedures for the municipalities. This year, OGM has passed a study on strength grading of national wood. So we are pretty much ready for the usage of timber structures in the short future. Cost is very important for civil engineers and the constructors. There is a comparison study in Canada, which is, you can reach to the details from this link. They have tested a 6-story house, and they found the cost, if it is made out of steel, if everything is from concrete, if the first floor is concrete, 5 levels are wood, and if all levels are wood. So as you can see at the bottom, 1 plus 5 or 6 floors of wood always has a better cost advantage, like 11 to 12%. And this doesn't include the early finishing, which Helena has just mentioned. Now, about the psychological barriers. These are some of the barriers that even my wife has. So we argue every now and then. People think timber structures are weak against fire, that bugs would eat them because they are organic. It would degrade and corrupt very quickly, and there might be mold, whatever, so it won't last long. And it is difficult to heat during winters because poorly heat insulated, and it is not as strong as concrete and steel. I think I have just ruled out the last item, but if you think about the fire, actually, it is much better in many of the cases because it burns out slowly, and there's this charcoal developing, so you can easily attain this 60-90 minute requirement. Whereas for concrete, if your tension rebars are melted or exceeding 600 centigrade degree, then you could lose your beams. The same thing for steel. And in a fire, you can easily go up to 1000 centigrade degrees in less than a minute. So here's this famous photograph of timber surviving the fire, the steel and rebars from the concrete just lie on it. So this is very often seen. Bugs can eat. There's timber impregnation that if you want, you can have some post-treatment of timber to protect it from mold, humidity, and bugs. So it is done in big storage tanks, and these chemicals go in once and then it stays there. Or you can have some sort of varnish on the surface, and when the fire comes in, it just expands and doesn't allow the oxygen to pass into the timber. So you see 3 examples here that with the treatment, and it is clear until the fire comes in, and then your structure doesn't collapse and doesn't burn. It is called intumescent painting or coating. When it comes to difficult to heat or warm up, the wood has a thermal conductivity of 0.13. It is just next to the insulation materials, 3 or 4 times this. But if you compare this with concrete, you see that concrete has a much larger value, 0.13 versus 20. So steel is nowhere near. It is more than, I don't know, 100 to 300 times. And if you use some foam, thermal insulation foam between the voids, then it is the perfect thing to use for winter and summer heating and cooling. So you can see the thermal insulation here in addition to the timber, which would make it perfect. So for the final words, production of timber uses solar energy because, as you know, all of the plants through their leaves use the solar energy, and the raw material comes from the air, which is carbon dioxide. So timber uses carbon in the air. It has negative carbon dioxide emission and is smallest footprint compared to other construction materials. It's a super material from strength, mass, thermal conductivity, carbon dioxide storage, and things like that. It has advantages for earthquakes. 95% of the people in Turkey are living in earthquake-prone regions. By land, 95% of the land is susceptible to earthquakes. Cost and fast construction and fire, these are all advantages. It is sustainable. It's a green technology. And most likely timber is going to be the construction material of the 21st century. I thank you very much for your interest in listening. So hopefully I'm not over my time too much.
Thank you, Ahmet Bey. It was a very sophisticated presentation.
Thank you.